In the vast expanse of space where human ingenuity and technological prowess meet, the European Space Agency, ESA, is preparing for a historic moment. As the calendar turns to September 2024, one of ESA's most ambitious and groundbreaking missions will come to a dramatic conclusion: the controlled re-entry of the cluster satellite, Salsa. This event is more than just the end of a satellite's journey. It symbolizes a new era in space exploration, where sustainability and responsible stewardship of space are paramount. A legacy of exploration, the cluster mission. To understand the significance of Salsa's re-entry, we must first delve into the legacy of the cluster mission. Launched in the summer of 2000, the cluster mission was designed to study the Earth's magnetosphere, the region of space dominated by Earth's magnetic field. This protective bubble shields our planet from the harsh solar wind, a stream of charged particles emanating from the sun. Understanding the magnetosphere is crucial because it plays a vital role in protecting life on Earth and maintaining our planet's atmosphere. The cluster mission consists of 4 identical satellites, each named after a dance style: Salsa, Rumba, Samba, and Tango. These satellites were deployed in a unique tetrahedral configuration, allowing them to measure the 3-dimensional structure and dynamics of the magnetosphere with unprecedented precision. Over the years, the data collected by these satellites have revolutionized our understanding of space weather, how solar wind interacts with Earth's magnetic field, creating phenomena like auroras and magnetic storms. Originally, the mission was intended to last just 5 years, but the robust design and careful management by ESA's mission controllers have allowed it to continue for over 2 decades. During this time, the cluster satellites have provided invaluable data that has informed not only scientific research, but also practical applications, such as improving the accuracy of space weather forecasting. This has direct implications for safeguarding satellites, power grids, and communication systems on Earth from the potentially devastating effects of solar storms. The journey of Salsa, a satellite's life in space. Salsa, like its counterparts, has had a remarkable journey through space. Orbiting Earth at altitudes ranging from 17,000 to 117,000 kilometers, Salsa has ventured far beyond the orbits of most satellites. This highly elliptical orbit has allowed Salsa to probe the magnetosphere at different distances from Earth, capturing the interactions between the solar wind and Earth's magnetic field from various perspectives. One of the most significant contributions of the cluster mission has been its role in understanding magnetic reconnection, a process where magnetic field lines from different magnetic domains collide and reconnect. This process is a fundamental driver of space weather, responsible for triggering solar flares and coronal mass ejections from the sun. The data from cluster has provided new insights into how magnetic reconnection occurs and its effects on space weather, helping scientists develop more accurate models to predict these events. Salsa has also been instrumental in studying the Earth's bow shock, the region where the solar wind abruptly slows down as it encounters the Earth's magnetosphere. By passing through the bow shock multiple times, Salsa has helped scientists understand the complex processes that occur in this turbulent region, shedding light on how energy is transferred from the solar wind to the magnetosphere. But Salsa's journey has not been without challenges. Over its 24-year mission, the satellite has endured the harsh conditions of space, from intense radiation to extreme temperature variations. In 2010, a software glitch threatened to end the mission prematurely, but thanks to the ingenuity of ESA's engineers, a workaround was implemented, allowing Salsa to continue its mission. This incident is a testament to the resilience and adaptability of both the satellite and the team behind it. A planned re-entry, ensuring a safe and controlled demise. Now, as Salsa approaches the end of its mission, ESA has taken the unprecedented step of planning a controlled re-entry for the satellite. In January 2024, ESA mission controllers used the remaining fuel on Salsa to lower its orbit, reducing the satellite's perigee, the point in its orbit closest to Earth, to approximately 100 kilometers. This maneuver was carefully calculated to ensure that Salsa would re-enter Earth's atmosphere and burn up, with any surviving debris falling harmlessly into the remote waters of the South Pacific in a region known as Point Nemo. Point Nemo, also known as the oceanic pole of inaccessibility, is the point in the ocean farthest from any land. This desolate region has become a favored location for space agencies to dispose of decommissioned spacecraft. Over the years, numerous spacecraft, including the Russian Mir space station and ESA's automated transfer vehicle, have met their end here. Even the International Space Station, ISS, is expected to be deorbited over Point Nemo around 2030. The decision to conduct a controlled re-entry of Salsa is not just about ensuring safety on Earth. It's also about advancing our understanding of how satellites disintegrate during re-entry. By carefully monitoring Salsa's descent, ESA aims to gather valuable data on which parts of the satellite survive the intense heat and pressure of re-entry, and in what condition they reach Earth. This information is crucial for designing future satellites that leave behind no trace, what ESA calls zero-debris satellites. The growing challenge of space debris. The controlled re-entry of Salsa is part of a broader effort by ESA and other space agencies to address the growing problem of space debris. As the number of satellites in orbit increases, so too does the risk of collisions and the creation of additional debris. This debris can pose a serious threat to both crewed and uncrewed spacecraft, as well as to vital infrastructure in space, such as communication satellites in the ISS. Currently, there are over 30,000 pieces of debris, larger than 10 centimeters orbiting Earth, and millions of smaller fragments that are too small to track, but still capable of causing significant damage. The accumulation of space debris has led to a situation known as the Kessler syndrome, a scenario in which the density of objects in low Earth orbit is high enough that collisions between objects could cause a cascade effect, generating even more debris and potentially rendering certain orbits unusable. To mitigate this risk, space agencies are adopting new guidelines and technologies for the responsible disposal of satellites. The controlled re-entry of Salsa is a prime example of these efforts. By ensuring that satellites are safely deorbited at the end of their mission, space agencies can prevent the creation of additional debris and help preserve the long-term sustainability of space activities. ESA is also developing technologies to actively remove space debris from orbit. One such project is ClearSpace 1, a mission scheduled for launch in 2025 that aims to capture and remove a piece of debris from orbit using a robotic arm. This mission will be the first of its kind and represents a significant step forward in the global effort to clean up space. The future of space, weather research. Beyond cluster. While the cluster mission is drawing to a close, the study of space weather is far from over. ESA is already planning the next generation of missions that will build on the legacy of cluster and take our understanding of space weather to new heights. One such mission is the Solar Wind Magnetosphere Ionosphere Link Explorer, or SMILE. Scheduled for launch in 2025, SMILE is a joint mission between ESA and the Chinese Academy of Sciences. The mission will study the interactions between the solar wind and Earth's magnetosphere using a combination of imaging and in-situ measurements. Unlike Cluster, which primarily focused on the magnetosphere itself, SMILE will also examine how these interactions affect the Earth's ionosphere, the region of the atmosphere that is ionized by solar and cosmic radiation. This will provide a more complete picture of the entire space weather system, from the Sun to the Earth. Another upcoming mission is Prabha 3, a solar observatory that will use a pair of satellites flying in formation to create an artificial solar eclipse. This will allow scientists to study the Sun's corona, the outermost layer of the Sun's atmosphere, in unprecedented detail. By understanding the processes that drive solar activity, such as solar flares and coronal mass ejections, Prabha 3 will contribute to our ability to predict space weather events that could impact Earth. These missions represent the next chapter in the study of space weather, building on the foundation laid by Cluster. As we continue to explore the dynamic and interconnected system of the Sun and Earth, the insights gained from these missions will not only advance our scientific knowledge, but also help protect our increasingly space-dependent society from the potential hazards of space weather. The broader implications, space exploration and sustainability. The controlled re-entry of Salsa also has broader implications for the future of space exploration. As humanity's presence in space continues to grow, with new missions planned to the Moon, Mars, and beyond, the need for sustainable practices becomes ever more critical. The lessons learned from the cluster mission and Salsa's re-entry will inform the design and operation of future spacecraft, ensuring that they can be safely deorbited or repurposed at the end of their missions. Moreover, the international collaboration that has been a hallmark of the cluster mission and other space weather research efforts highlights the importance of global cooperation in space exploration. As space becomes more crowded and the challenges of space debris and space weather become more pressing, it is essential that nations work together to develop and implement solutions that benefit all of humanity. In this context, the controlled re-entry of Salsa is more than just the end of a mission. It is a symbol of the responsible and sustainable approach that will be necessary to ensure the long-term viability of space exploration. By taking proactive steps to manage space debris and advance our understanding of space weather, ESA and its partners are helping to pave the way for a future where space is accessible, safe, and sustainable for generations to come. Conclusion: the final dance of Salsa. As Salsa makes its final descent, it will mark the end of an era in space exploration. The cluster mission has been a pioneering endeavor, pushing the boundaries of our knowledge and demonstrating the resilience of both technology and human ingenuity. The data collected by Salsa and its counterparts have deepened our understanding of the complex and dynamic relationship between the Sun and Earth, with implications that reach far beyond our planet. But as we bid farewell to Salsa, we also look forward to the future. The insights gained from the cluster mission will continue to inform new missions and technologies, driving further advances in space weather research and satellite design. And the lessons learned from Salsa's controlled re-entry will contribute to the ongoing effort to make space exploration more sustainable and responsible. In the end, the last dance of Salsa is not just a conclusion, but a beginning, a new chapter in our journey to explore and understand the cosmos. As we continue to reach for the stars, we carry with us the knowledge and experience gained from missions like Cluster, ensuring that our exploration of space is not only bold and ambitious, but also mindful of the responsibilities that come with it. The story of Salsa and the Cluster mission is a testament to the power of human curiosity and the enduring spirit of exploration. It reminds us that, even as we push the boundaries of what is possible, we must also strive to protect and preserve the space we explore, ensuring that the wonders of the cosmos remain within reach for all who follow.